I'm looking to meet Sarah. See Sarah now. Today should be quite a bit shorter than yesterday. I'm still building your test. I'm about 2/3 of the way done with it. That just means that the digital version, the Kahoot's, gonna be really plain. I don't know how many images I can throw into it. I'm trying to pull up all the right stuff here. I put the quaternary into parent portal. At the end of everything, I'll let people know who's still missing the one from the Ice Age megafauna, the big beasts. Whatever I'm hearing off, please. For today's opener, and I should have switched this. From what was in Canvas, because it was actually a duplicate of yesterday's. I just made a boo-boo when I was copying and pasting from the assignment over into Canvas. How long ago did we start cooking food? When did we start controlling fire? I know I mentioned this yesterday. When did we do this? Or which species of human was able to do this, if you don't remember the year? Y'all don't remember. Who was the nomad? Who was the one that left Africa? Which species of Homo was it? Okay. No, it's not. Hayden! It's not what. It's not what Homo means in this case. It means man. Which primitive man actually left Africa? Which species of Homo was it? Erectus. It was Erectus. All right. So this is about, give or take, and I can't put an exact month and day to this. 1.8 million years ago was when we learned to control fire, and we actually started cooking food. That's when our brains really started accelerating in size. So when did we start eating meat? This was before this. We ate raw meat for a while. When did we start eating meat? How long ago?
Oh, you said this yesterday.
I did say this yesterday. Yes, I did. I did.
2,000
No, it was way longer than that. 2.6 million years ago.
I was on the right track. It was 2 something.
It was 2 something. You're correct. Now, what eating meat did was it started accelerating brain growth. The amount of protein that a species has in its diet is 100% correlated to the size of the brain. So we started getting much larger brain capacity, which was measured in cc's, which is what we talked about yesterday, by the amount of protein in the diet. Now, insects count as protein, which is gross, but we didn't have fire for 800,000 years. We were just eating raw meat, raw flesh, animals, whatever, fish, insects, gazelle, whatever the heck the previous hominids came across, until the Homo erectus species, I think that was an email noise, until the Homo erectus species figured out how to control fire. Now, I totally forgot to get my arrowheads yet again. What was that ding? We should make arrowheads. It's not hard. Please excuse Fallen Girls at 1:30 on Wednesday. Okay, no, it's not. I gotta pull up the right tab. There we go. All right, we are going to pick up what we left off yesterday with mitochondrial Eve, and how we migrated out of Africa, and then also the intellectual developments, like when did we start art, when did we start music, when did we learn to start speaking, that kind of stuff. I thought about possibly including weaponry in here, but I don't have enough time to talk about the Stone Age versus the Bronze Age. Like, I easily could have expanded human evolution for a couple more lessons, but we don't have the time. I want to review for the test tomorrow, and then the test will be Thursday, and I'll give you guys something nice and easy and cushy on Friday, which is the asynchronous day. If you don't log in and answer the prompt, then I cannot count you present, and that has to shut off at 11:59 Friday evening. Yes. So we have to. Now what? They can't do this before school starts? No, apparently not. Aren't these people supposed to be teaching right now? No? All right. So yesterday we left off with mitochondrial Eve. We understood what DNA was in the early 50s, but we couldn't actually extract the DNA and analyze it until the early 70s. We didn't map the human genome until 2001. So this is something that's much more recent. I did not know this when I was your age. It's something that happened actually while I was in college. But we took the rate at which mitochondrial DNA, not nuclear DNA, nuclear DNA is different, but within the powerhouse of the cell, everybody learns that in biology, its particular DNA doesn't replicate like the nuclear DNA does. So that means that the only way that it changes is by genetic mutation. And we know how often that happens, so we applied that rate to how different we are from each other and figured out that approximately 200,000 years ago, we came from the same specific population of, we were Homo sapiens at this time, but that particular type of hominid. Now, I guarantee you what I'm teaching you right now is going to change. I guarantee you it, because this is new technology. And as we get better technology, we get better numerical, hard data. From what I read, and like I said, this is way different from what I was taught, about 100,000 years ago, our specific type of Homo sapiens branched out. So Homo sapiens, if you go back to more recent modern humans, that was erectus about 1.8 million years ago, but Homo sapiens itself didn't really start till about 200 to 300,000 years ago. But there's a specific branch about 100,000 years ago that we're all related to. Capital H just stands for Homo. Homo erectus radiated 3 major times. The Hobbit, the Heidelbergensis, I still don't think I'm saying that right. The Neanderthals, and then us, Homo sapiens. But they all, depending on which of the two theories you agree with, they either came from erectus or sapiens just pushed everything out. And Homo sapiens was just the dominant of the hominid species, and so therefore it won the fight. Not like fist fight, but the genetic fight. No, you don't go fight. When I was your age, we thought that we split about 20 million years ago. It was anywhere from 5 to 20 was what I was taught when I was your age. Since we have mapped the genome and we understand the mutation rate specifically of the mitochondrial DNA that has come much more recent to 5 to 6 million years ago, a couple of the species that we talked about yesterday would have either been pre-chimp split or possibly the direct ancestor that happened at the chimp split. The first one we talked about yesterday was about 6.5 million years ago. The second one was 6. Like I said, I fully expect what I am talking about right now to change. It's not that I'm trying to mislead you. It's not that at all. It's just that our technology is changing that quickly. And like I said, Watson and Crick did their thing with DNA in 1953. But we couldn't, and I've done this in college. You take the genetic material and you put it in what almost looks like a little teeny tiny plastic vial. It's what we use with pipettes. And it denatures the protein. And then you take the denatured protein and then you inject it into the holes in the electrophoresis gel. And then you shut the top and you tell it to go, and it electrifies it, and it runs the DNA, the proteins, through the. Have you ever seen like Petri dishes? That's the texture of electrophoresis gel. It's like a gooey is not the right word, like a jellyfish kind of material, if you will. And then we read those. It looks like almost like a barcode as it pushes it up through the gel. We didn't learn how to do that till the 70s. I did that in the late 90s and early 2000s in college. I don't know if they do that in high school. I don't think they do. Somebody's trying to come in. Yeah, but I guess I would advise going to A-Hall. There's Colton. This. I'm focusing more on how we process this mitochondrial DNA. It just amazes me how much things have changed since I was your age. Nuclear DNA is different than mitochondrial DNA. Nuclear DNA is, we all have it, and when you're conceived, you get half from your mom and half from your dad. And as it replicates, it has a higher chance of change, whether that be mutation or just telomere truncation or whatever's happened to the actual genetic code. Mitochondrial DNA is different. Like I said, it's within the mitochondria itself, and it has a very specific mutation rate. That's what we use to figure the stuff out. It acts as a molecular clock, a biological clock. And that's how we know that we shared common ancestors as humans 200,000 years ago-ish, and with chimps 5 to 6 million years ago-ish. The further back in time you go, the more broad that number's going to become. Now that, like I said, this may change. This may change with technology. I don't know what's going to happen in 20 years from now. I mean, heck, 20 years ago, we didn't have cell phones. Did you even have car phones 20 years ago? Yeah, I think you did. Cell phones were just starting 20 years ago, but they were analog. They were different. They were like the Zach Morris phone kind of thing from Save from the Bill, but whatever the name of that TV show was. So like I said, this is a changing thing. Our more modern human species started with Homo erectus, which was about 1.8 million years ago. Homo sapiens itself didn't really take off from 200 to 300,000 years ago, but our more modern person, less hair, less ape-like, completely bipedal, could harness fire, still wasn't wearing clothes yet. That was a much more later development when we figured out we shouldn't be running around naked everywhere. Much more recent one. So mitochondrial, which is what the MT stands for, DNA, is what unlocked everything. It only comes from your mother. I'm so sorry, guys, but sperm does not carry mitochondrial DNA. It's carried by the egg. There's just not enough space with the sperm. You've never seen any of the graphics. Sperm are way smaller than eggs. Way smaller. That's one of the reasons why females in certain species are larger, because our sexual organs are much more taxing than males, specifically insects and reptiles. I do not know which specific races they pulled from. And I meant to go back and look this up, and I ran out of time yesterday to do it. But just under 150 different human beings, both male and female, we took blood protein samples, so, yank their blood out of their veins, from 5 different populations. Now, I would have to assume it would be Asian, African, Native American, which is almost Asian. Now, I don't know about the others. I don't know specifically which backgrounds they pulled, but they analyzed how different their DNA was from each other. And this is what let us go back to that approximately 200,000 years ago age for mitochondrial Eve. Yesterday, we talked about how Africans have the greatest genetic variation. The more variation you have, the older that population is. So this is how we know that we came out of Africa, is because a indigenous African, I don't care what color your skin is, an indigenous African is going to have more genetic differences than any other population, because that's where we started from. As far as Homo erectus, the one that left Africa, the further they went, the smaller the family units were that colonized that area, and the smaller the genetic pool became. So they have less genetic variation. I should have put in your canvas, I think, one of the migration maps. I don't know if I did. I put it in your canvas because it's on here. Well, at least I think I put it on the canvas. So Homo erectus, 1.8 million years ago, was established. They really started migrating. Both erectus and ergaster started migrating about 200,000 years ago. This was the introduction of Homo sapiens somewhere between 200,000 and 300,000 years ago. Like I said, there's no book for me to try to run this class. I'm having to constantly reference and cross-reference from different universities. So I'm seeing a fluctuation of dates. When I was your age, they set up to about 20 million years ago for the split from the great apes. If that's true, then there would have been a larger differentiation in the genetic code. We share, here, let me cheat and trust the internet's not gonna lie. I want to say we have 98% of chimps DNA. Let's see. What percentage of DNA do we share with chimps? Okay, 98.8%. Well, at least that's what the internet says, and the internet never lies. The difference, like I said, just like we did with other human beings, the difference in mitochondrial DNA that we have from chimps, we applied the mutation rate to that, and that goes back from about 5 to 6 million years ago. You don't necessarily need to know the 2 different scientists that work together, Alan Wilson, and then not Winston, and then his protege or understudy or whatever you call the person that works underneath somebody. They compared these blood proteins, these mitochondrial DNA blood proteins between chimps and humans, just like we did between various humans, to calculate this ancestral time period. And like I said, the first couple that we looked at yesterday the first one definitely that was from Chad Africa would have been pre-split. The second one, which was at 6 million years ago, I don't know. I can't tell you for sure that that is the last type right before the split or if it was after the split. It gets a little blurry the more close to the time split, and we don't have a complete fossil record either. Not everything has been preserved. We know that the lemurs split first, then you had your new and your old world monkeys, things like capuchins and tamarins. Then you had orangutans, and then you had gorillas, and then you had chimps right before us. That's why we share more of our DNA with chimpanzees. I know when I took my kid to the zoo, which everybody's entitled to their evolutionary versus biblical belief, I guess. But I was explaining to my child how we share so much DNA with chimps, and somebody behind me got all hissy and sort of went off. And I was like, yo, let me educate my child. You go do your thing. I do my thing. And she did not appreciate the fact that we share DNA with chimps. And she goes, well, we came from God. And I said, well, everything came from that. We all share DNA. We share DNA with bananas. We get everything from this planet. They are specific species. We don't know if we came specifically from Erectus or if we just pushed everything out. But Homo sapiens replaced everything. There were multiple species that were alive at the same time. Erectus was still around 20,000 years ago, which leads me to believe that sapiens just were superior and pushed everything out. But there is still the idea that Erectus eventually just turned into the different sapien races, which is why we have specific traits with Asians and specific traits with the indigenous Australians, which look more primitive, but believe it or not, they're one of the last radiations of Erectus, or at least from what I pulled out of my research. Interbreeding, there's a question mark here for a reason. We don't know for sure. Most likely different species of hominids interbred, okay, but we don't, that's not something that's going to be preserved in the fossil record. I should have mentioned this yesterday. Somebody had asked, would they cannibalize each other? I'm pretty sure that different Homo species would have competed for the same resources. Now, did they just go and kill the other ones and eat them? That also is not recorded in the fossil record. This is way pre-cave art, so there's like no anything to take a look at. But the earliest of the cave art was like 40,000 years ago. The further a species moved out of Africa, the shallower the gene pool becomes, the less genetic variation. Like I said, the most genetic variation is indigenous African. Now, the number I gave you for mitochondrial leaf before was approximately 200,000 years ago. They have a range now of 140 to 225,000 years ago. So the 200 is just sort of smack dab in the center. Like I said, that the further back in time, the more blurry the edges of these dates become. Let's see what that is. See what that is. Communities and schools out of office Wednesday, March 31st. Okay, that's awesome. Let's get rid of that. Wrestling absence. Okay, I do have a student on that list, so I can't get rid of that. You guys have probably seen this image before. It's like in every biology book, like ever. This is the the evolution of man, if you will, that we shared common ancestors. Australopithecus would have been the first more our side of the branch. Habilis was the first tool user. Erectus was the one that left Africa. This is the one that looked more like us than anything else. The Neanderthals were a little bit shorter than us, but they were stockier. They had larger brains, or at least the same size, if not larger brains, but they were built for the cold. And we have sapiens at the very, very, very end. We did start controlling fire at about 1.8 million years ago. This was the habilis was the species that started eating more meat. And by the time Erectus came around, the brain size was quite a bit larger. And we started actually being able to understand the environment and start controlling the environment, specifically with the Erectus, which is why that's, and ergaster for that matter, which is why they're such an important part of our evolution. All right, when did we start getting smart? There's a few slides for this. We started farming and the domestication of animals somewhere between 10,000 years ago and 12,000 years ago, so about 10,000 BC. This is when that Mesopotamian population was doing their thing, which is modern-day Iraq, between the Tigris and the Euphrates rivers. The first plants that we started were grasses, okay? I know you think of grass as just the crap that you walk on, but they're anything that has that tuft of seed at the top when it's getting ready to populate itself. So wheat, legumes or beans, if you don't know what a legume is, figs, which are delicious if you've never had a fig off of a fig tree. And then oats. Corn falls into this category. Corn is a very, very, very strange grain. It's almost like it's extraterrestrial. And the first domesticated animals, Mesopotamia is so special because of the animals that were present there that could be domesticated. You cannot domesticate a zebra. You cannot put a saddle on a zebra and ride it around. It's not going to happen. You can do that with a horse. You can do that actually with cows too. You can train them to jump over things and all that kinds of stuff. But in Mesopotamia, specifically sheep, goat, the bovine, cattle, ox, that family, and the pig. This is the same time that we started domesticating dogs from wolves. So somewhere between 10 and 12,000 years ago, give or take, is when people started populating the Mesopotamia area. I think there's one more on here. There's not. So understanding farming happened at this time. Irrigation happened at this time. Up until we understood how to dig ditches for irrigation, humans were completely and totally stuck to water. There's a reason why, whoops, let me go back. Oh, there was not much on this one at all. There's a reason why your older cities are all along waterways. Those were our roads. We didn't have cars and airplanes and all the different kinds of travel for forever, like we do now. Your first warehouse, if you will, started about 9,000 years ago. 8,000 BC is the same thing as 10,000 years ago. You got to remember we're 2,000 years into AD, Anno Domini. So this is 8,000 BC. All of these were happening at approximately the same time. But we didn't actually have what you would consider a modern warehouse. Obviously, we don't have refrigeration. We don't have electricity or anything like this at this point. But the storehouses, the warehouses, came a little bit after that to be able to store the grain for colder months. Now we're in Africa. Actually, we're not in Africa. We're in Iraq at this point. It stays warm pretty much year round there. So you didn't have to worry about keeping things from freezing. Let's see, what do we have on the next ones? I had people start asking me about weaponry, and I did not go into that. I did not go into the difference between the Bronze Age, the Stone Age, all of that. I can't fit it in here. It's too much stuff. I could easily have had 2 more lessons on here. All right, so this flow chart, I believe, is in your Canvas. Homo erectus, like I said, is the most important evolutionary change. Yes, I know we're Homo sapiens, so that means more to us specifically, but Homo erectus is the one that left. You've got your oldest of humans, which were the Africans, the indigenous Africans. They went to Europe next. So Neanderthals, possibly there's some of their genetic lineage in your Eurasians, but we know that they died out about 28 to 32,000 years ago. There's a very specific line of Asians, and there's a very specific line for Indonesians, which eventually became Australians. I know that indigenous Australians look more primitive facially, but they're actually one of the most recent radiations from Homo erectus. So once again, oh, that should be capitalized. I gotta fix that. That's gonna bother me. Homo should be capitalized. That is not right. Genus is capitalized. The species is not. Your like I said, your Homo erectus are unbelievably important as far as the different types of Homo sapiens. Depending on where they went and how isolated the populations were, that's what created the different races of human. I mean, honestly, your DNA and my DNA are almost identical compared to different kinds of species. I mean, we're not identical. We'd have to be biological twins, but still, anyways, there's a specific species of Homo sapiens that about 100,000 years ago seems to have been the radiation for everything else. That's what we're tied to. That is your infamous mitochondrial Eve. And I know that I keep saying that, 200,000 years ago, that's just a ballpark figure. No idea what my coworkers are texting me about that. Marshmallows. Marshmallows? Okay, I don't know. I don't know what they need marshmallows for. Okay, we are almost done. Did I put that map in the Canvas? I should have. The one that shows the migrations, yes, I did. If you do the 23 DNA thing where you swab your cheek and you send it off, and then they tell you where you came from, this next map is what they're going to refer to. It's just going to have a bunch of dates on it. This one does not have the dates on it. So Africa, so where we came from, and I know they can't see me pointing, where we came from is this generic area right here, the eastern part of Central Africa. Mesopotamia is right here. So they left Central Africa to Mesopotamia. This is the part where we branched out. Now, this is much, 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 much later. And I know if you do the whole cheek swab thing, these will have different dates on them. I did not put that particular map up here. I can't figure out where I found it in the first place. I can't find it again. But this is how humans spread out through the rest of the world. And our branch for North America, which I don't, all of us are a mix of everything at this point. North America is nothing but a mutt of people. This particular line spread out about 14,000 years ago, the one that has the question mark up on the top right-hand side. All right, so When did we start doing stuff? We started eating meat 2.6 million years ago. This was the major advance for the larger brain size that allowed everything else to happen. Homo erectus was the species that started to learn how to control fire and started cooking their food. Our larynx, our voice box, the thing that lets us have the spoken word, did not develop until about 200,000 years ago. So speech is a much more recent evolutionary adaptation. Not that cavemen couldn't point and like grunt and stuff. They could do that, but the spoken word, the control of the sounds that come out of our throat, that didn't happen until much later. We didn't start wearing clothes till 100,000 years ago. We just ran around naked. Now, with the loss of hair, we started wearing animal skins because we were cold. Yeah, but like I said, this didn't happen until about 100,000 years ago, give or take. Music is an older adaptation. The same time that we actually started controlling pigment and cave art, they happened simultaneous. Farming didn't start until we moved off to Mesopotamia. That, like I said, that's somewhere between 10 and 12,000 years ago, give or take. Same thing, same time that we started domesticating animals. One of the most important things that we figured out was the wheel. That wasn't until 4000 BC, so 6,000 years ago, give or take. But the wheel was a huge change. I don't think there's anything else on this one. Oh, there is one more. It's the same time that we invented the original archaic plow. So not like what we have today with the machines that do it, but you would attach the, looks like a shoehorn is what the original plow looks like, to the back of a horse or some type of cow. This was a huge thing for cultivation. Even though we started farming where is it at? We started farming quite a bit earlier. You literally would poke a hole in the ground with a stick, put seeds in it, cover it up with your foot, and move on. This was the same time they actually started irrigation as well. But modern farming wasn't until quite a bit later. You could go much deeper and you get more nutrients out of the soil. All right, Neanderthals. I'm going to talk about Neanderthals specifically and then Homo sapiens specifically, and we're through. Neanderthals existed in Eurasia, so Europe, and the Middle East. I was misled as a child. I thought that they were here in North America along with Homo sapiens. That's not true. Their brain was just as large as ours, if not larger. They were just as body size massive as us, but they were shorter. One of the things that the Neanderthals are contributed to is burying their dead. That wasn't always the case. Eventually, they started burning dead when you go later on. Some of them would put their dead in caves. There's so many different civilizations that I could talk about right now, and we just don't have the time. Tools started with habilis. Okay, so they had both stone and wood tools. Spears were around at this point in time. I did not go into weaponry as far as like when did the bow and arrow show up, when did gunpowder. I know that's Chinese. I know gunpowder is Chinese, but specifically time frame, I didn't go into any kind of weaponry. Neanderthals were primarily meat eaters. Homo sapiens are omnivorous. Now, here's a question mark again. Did we interbreed? Most likely there was interbreeding between the species. Like I said, that's impossible to see in the fossil record. Somebody asked me about Bigfoot the other day. No, I'm not going to talk about Bigfoot. Somebody else talked about the Loch Ness Monster, but no. So there most likely, yes, interbreeding between different Homo species. All of the different Homo species happened. We just do not have fossilized evidence of any of this. And like I said, written language wasn't until quite a bit later. Homo sapiens, on average, our lifespan is 80 years. Our sexual dimorphism is very low. Yes, I know some people are freakishly huge and some others are quite a bit smaller, but in general, male and female size is the same. What makes us different is this part of the brain, the front of the brain, the prefrontal cortex. I can see that easily. The part where if you drill into somebody's brain, you give them a lobotomy, and then they become like a zombie, if you will. Not like Walking Dead zombie, just like non-thinking, just do what they're told kind of thing. This is the part that lets us rationalize. This is what makes us so much different than the rest of the animal kingdom. And like I said, this particular model, there's so many different models, and I don't have enough time to go into all of them, but the most accepted does show that there was interbreeding between the different Homo species. The most accepted method or model has Homo erectus as basically the grandparent of all Homo sapiens. That's why we have different races, is the specific erectus groups that move to different places. I really could have spent a lot more time on human evolution, but that is actually making this more of a biology class and less of an earth space. And I need to start moving off to, let me pull up my thing for online. I really need to start moving on to